topic now with COVID testing. So, false positives and false negatives. I feel like I used to have to explain this. I might not have to explain it as much in this climate. I don't know. I don't know the actual COVID numbers, so I don't want to put them up here because 3% of the population has a certain disease. So we know that there's like a 3% chance that if I test a random person in the population, they'll test positive. They don't test that. They'll have the disease. 3% of people have the disease. If you do have the disease, there's a 10% chance that you'll get a false negative. So that means you get a negative result, but that's false, meaning you actually have it. There's a 5% chance you get a false positive. So you get a positive that's false, meaning you test positive, but that's false, you actually don't have it. Find the probability that a randomly selected person tests positive. We're going to go through how to do this. The diagram isn't really going to get you there. This is a different style. This is a different kind of problem. I like that diagram. It won't work here. So, I'm going to do it, and then I'll change the numbers and have you guys count. Is that good? So, there's two kind of decisions. There's two branches. I'm going to make a tree. My first branch is the percent of population that has disease. They have a certain false positive, false negative rate. And then if you don't have the disease, it's kind of different. So I'm going to say, okay. So I'm going to say, has disease. There is a 3% chance that you have it. And then if you don't, so what percent is it? What's the percent chance I don't have it? Will be 0.97, right? So those two just had to add up to 100%. You could be right like that. So, all right, if you have the disease, you could either, and I'm going to test you, you could test positive or negative. If you have the disease, there's a 10% chance of a false negative. So that's this branch right here. False negative means you have the disease, but you tested negative. So the test is wrong, it's false. So then what's the probability that you would test positive if you have the disease? Like what number goes right here? 0.9, because 10% of the time the test is wrong, which means 90% of the time the test is correct. Right? So then if I don't have the disease, again, I could test positive, I could test negative. So if I don't have the disease, there's a 5% chance of a false positive. So your false positive is right here. You do not have the disease, but you test as though you do. So the test is wrong. What's up? You guys good? Okay. And then there's, so what percent chance is it that the test is correct? 95, right? 0.95. So then with these trees, what you do is you multiply like the branches. So over here, I'm going to say, okay, the probability of having the disease and testing positive. So remember that like upside down U and it's like an intersection. I know that looks weird, D symbol plus, it looks like some Greek letters or something, but that's just disease and positive test is 0.03 times 0.9, so 0.27. So the probability I have the disease and I test negative is 0.03 times 0.1, so 0.003. This is like the worst case, right? If you have the disease, let's not get into COVID, whether it's a big deal or not, but let's say it's cancer. You have the disease, but you just tested negative. So you think everything's fine. Meanwhile, cancer is like ravaging through your body. So this is what they really try to avoid. This false negative. Don't have the disease. So I'll say like no disease, ND. Is that cool? and test positive. 0.97 times 0.05. So what is that? 0.0485. Am I do that yet? Pretty sure that's right. 0.0485. Thank you. And then probability of no disease and test negative is you multiply those two branches together. So 0.97 times 0.95. You got that one? Thank you. So one way to check at the end, it doesn't guarantee you're correct, but it tells you you're like probably on the right path. What do all four of those things have to add up to? They have to add up to 1, so you might want to quick check that when you're doing these on your own at a test or something. So, what? Oh, thank you. I forgot a zero up here. It's 0.027. This one good? Yeah, that was good, right? Okay. Question on how I'm getting those numbers. Because then, basically, once you get those numbers, you can answer any of the questions they ask. So find the probability that a randomly selected person tests positive. So there's two ways that you can test positive. You can test positive here, or you can test positive there. So you would add those up and say 0.027 plus 0.0485. Sam, what we got?
0.0755.
Thank you. Or I could say what's the probability that test negative. I mean, I could ask a few different questions there, but just making the tree is the part I wanted to go through. Because the only trees we've done was like this probability was the same every time. Like head, tails, head, tails, head, tails. It changed, so this is an example of that. Question on any part of that process? Where'd you do this? Why'd you do this? Any help with there? Alright, let me just change the numbers on it. You guys try it. I would erase your, like, I know you could just leave the tree and, like, just change the numbers. I would start all over to make sure you're not cheating yourself, you know. Let's say 5% has the disease. If you have it, there's a 6% chance you get a false negative. If you don't, there's a... Alright, try that. Don't cheat yourself. Erase it all the way. It's just water. Yeah, but the water's not nasty. Buy some spray though. Same. Water really doesn't get it off. Again, a nice way to quick check after you've done it is those probabilities should add up to 1. Contact quarantine. I had a question here at the end. So we didn't do this question on the first one, I just kind of forgot. But try that one too. Find the probability they have the disease if we know they tested positive. They say lawyers should never ask a question they know the answers already. That's what you said. Not sure, don't ask. Well, there you go. It's not good. You guys were hanging with Chelsea for what? Okay. Which valley? You don't know which one started? You guys are playing Little Caesars? For what? Like against who? A regular league game. What's up? That's pretty sweet. Did you guys get those for your numbers? For okay. Questions on that anywhere? So 5% has the disease, then you either test positive or negative. 95% don't test positive or negative. Find the probability that a randomly selected person tests positive. Well, there's two ways you can test positive. That's those two, so 0.047 plus 0.076. Point 0.123. You guys get that for the first question there? So the second one, find the probability they have the disease given a positive test. So this would be, some of you guys did this the Venn diagram way. I think you're kind of stuck using the formula way for this question. So they have the disease, so yes, given a positive test. The formula for that is the probability of A given B is the probability of both divided by the probability of the thing that you know. So the probability of both would be the probability of yes and positive divided by the probability of the thing that you know. So the positive. So what's the probability of but your answers are all right in front of you. You already know the word for it. So what's the probability of yes and positive? It's 0.047. And what's the probability of positive? It's 0.123. You see where I'm getting those two from? They use to find those. So 0.382, let's say. So that's kind of wild to me. Like, those don't seem like really bad false positive and false negative rates. They are. What? I think it's. I'm struggling to think of how to do it. So maybe, but like off the top of my head, I can't get there. I'll look and see if I can think of one. Yeah, but you should learn how to use the formula for this too, I think. So like to me, this is pretty wild that those don't seem like high rates of mistakes for a test, you know. But even with those numbers, if you get a positive test, there's only a 38% chance they actually have a disease. So like real mistakes, like real testing errors, have to be much, much smaller than that to make the test have any value. Which you feel like 6% is not that big a deal, but when you do the math for it, it comes out to a pretty big deal. Yeah. Oh, I thought you were just okay. Questions on that one anyway? Alright. Try this guy. Yeah, I don't know about a Venn diagram. Unfortunately. So if a flight is delayed, it could be like by one method, by the other method, or by both methods, really. So, I like your strategy. So, there's two. Like, you either have a weather delay or you don't. I think you used the 15% for mechanic. You know what I'm saying? But I like what you're. That's kind of one of the points I want to make. As far as how it's that information. You like your morning sweater? Why do you say English? Because the was it like video media stuff? Going to an I. Yeah, gotcha. It's like a different world. There's like so in English, it's like to me there's like AP live classes and like English. Like that's what you were in like.
Well, no, I wouldn't go down. If I was in AP, that's my whole high school career. Just because it's my senior year, why would you?
I agree.
Yeah, that's not.
But like if there were a middle ground, that'd be kind of nice. It's not like guys every day. It's not learning what the group is. It's like something. I know what you're saying. Okay, so hey. So I love when people say that. That's not me. You're the one that swore. Obviously, it's not you. Like, who else would it be? Okay, 25% chance you get delayed because of weather, and then that affects like the probability of a mechanical delay. Because like if there's weather, you're kind of more likely to have a mechanical issue. Also, 75% of no weather, and then that affects this. So one thing you could do is where is there at least one delay? That has a delay. That has a delay, and that has a delay. So if you find all three of those answers and add them up, that's your answer. An easier, faster way, this is the only version with no delay, right? There's no weather delay, there's no mechanical delay. That's the only path that doesn't have a delay. So you could also find this and then do what with it? Subtract it from 1. So if you multiply these two together, it's 0.69. And then 1 minus 0.69 is your answer. So your answer is 0.31. Should I go through and put what these other ones are? So if you added up these three, it would get you the same thing. Just kind of going through it faster. I don't know. faster way. Questions on that one anywhere? Here. Did I multiply wrong? 0.25 times 0.85?
For weather, I just added the two. Just said 0.25 times 1. I got the same answer.
Because there's a delay either way. Right? So, like, yeah. Really, because what do these two things add up to? 0.25. You're right. There's no real reason to break them down because there's a delay either way. So I don't really care if it was like 2 delays or 1. It's just a delay. So you just cut all this out and we're like, it doesn't matter. It's just 0.25. And then you split up this part. Same thing. You just kind of shortcut it a little bit. Does that make sense what the difference is? Sure. Alright, I'm going to throw up a problem on your packet. You don't have to get it out. I'll just put it on the board. It's about eaglets. Eaglets are savage. Wait till you read this. I didn't know this stuff. I don't know if this is true or not, but they like prioritize the older sibling and make darn sure the older sibling, they feed the older one until it's full, and then if there's food left over, they feed the younger one. Savage. Is that big enough for you guys to read? If you want to get your packet out, it's number 28. So I want you to try this one. You can get your packet out, but the question I'm asking you is a little different than the one they're asking you. So the parents feed the older one until it's full, and then they feed the younger one. If the older eagle has a 50% chance of survival, and then if the older one survives, the younger one has a 10% chance. If the older one doesn't survive, the younger one has a better chance because they get more food now. I want you to try to find the probability at least one eaglet survives. And also be thankful that you're not an eaglet. Is that big enough for you guys to read the book? Well, you're blind no matter what. Okay. You know what I always do if I'm blind is sit in the very back of the class. So it's number 28. Just make sure you're answering the question I'm asking instead of the one they're asking. Yeah. It's kind of a yeah. Did you watch the videos? Did you watch the videos? I guess we know the answer. I recorded the lectures. We were saying hi to you and giving you shout outs. Now I really regret doing all of that. Jeez. Oh. But somehow you get the con done.
It's con. It's my favorite.
You good or should I wait a minute? Any thoughts? Would anybody like more time? People are still typing, so. Okay. So, I set it up like this. There's a 50% chance the old survives, and a 50% chance they don't, and then the young. If the old survives, the young is more likely to die. So we get this 0.1, 0.9, then 0.3, 0.7, then if you multiply them all out, you get these numbers. And I'm saying, what's the problem? Well, let me just set there. Any questions on where'd you get those numbers from? How'd you get that? I said it looked different. Anything I can help with here? But then what's the probability at least one survives? So you can add up those three numbers. Or this means nobody survives. So what could you do with that number? Do 1 minus 0.35 and your answer is going to be 0.65. How many have 0.65? Nice. Questions on that? One more. It's a little bit different, but similar concept. 18. So if you want to get your packet out, go for it. I'm going to look up here, go for it. I'll let you read through it, and I'll give you like a hint to get started, because it is a little strange wording. Is that your response to the question?
It's my response to the first sentence.
Read through it, I'll explain. So we're playing a game, some dice game or something, and 40% of the time, so I'm reading off this chart, 40% of the time I get 0 points, 30% of the time I get 1 point, 30% of the time I'm going to get 2 points. So that's what this says. And then the number of points obtained in one game is independent of the number of points obtained in the second game. So does my first result have any impact on my second result? No, that's what independent means. So like the game is, it's like a 3-sided die or something. There's no memory. It doesn't like know what the previous result was. I'm gonna play it twice, and I'm gonna add up my scores. Which of these values is the most likely after I've played it twice and added up my scores? No. Make a tree. So put 0, 1, 2 for your first here. So the first time I play, I can get a 0, 1, or a 2. And then off of all of those, I can get a 0, 1, or a 2, 0, 1, or 2, 0, 1, or 2. So I understand why you'd say 0, because that 0.4 is the biggest. But the only way you can add up to 0 is getting 0 both times. There's other ways you can add up to 2, or 1, or 3. Does that help you get started? So to get you kind of started, maybe we'll see. So I'll show you like my first part here. I don't want to show you the whole thing, but technical difficulties. So, like my first roll could be a 0. There's a 40% chance of that. And then my second roll could be a 0, 1, or 2. And if I rolled a 0 and then a 0, what's my sum for the 2 times I played? If I add up a 0 and a 0, I got a 0 total. And there is a 0.4 times 0.4 or 16% chance of that. If I got a 0 and then a 1, my sum is 1. There's a 16% chance of that. If I got a 0 and then a 2, my sum of those two rolls is 2, and there's a 12% chance of that. Then you got to do that for the whole chart, like all 3 of those branches, and see, and then add up. So I just keep going, like do it. Okay. So I want to make sure you understand what that number means and that number means. That number is the sum of the 2 rolls. So it's saying there's a 40% chance I get a 0 in the first roll, 40% chance I get a 0 in the second roll. So I multiply those together, that's 0.16. And what's the sum of those 2 rolls? It's 0, right? I got a 0 and another 0. Yeah. Oh, so that should be 0.3, shouldn't it? Thank you. Okay, is that better? Is that why you guys are staring at me like, what are you talking about? Part of reason? Okay. Does that help? Thank you. So then I've got a 40% chance and a 30% chance of getting a 0 and a 1, and if I add those two up, I get 1. Does this make more sense now? Have we figured that out? So then, if I go kind of look at the whole thing together, there's only one way I can get a total of 0 by playing twice. So there's a 16% chance of getting a 0. Well, I could get a 1 here or here. 0.112, 0.112, so there's a 0.24 probability of getting a 1. I can get a 2 there, or there. So I gotta add all those up, and that's 0.33. A 3 I can only get there or there, that's 0.18. And I can only add up to 4 if I get a 2 and then another 2, and that's 0.09. So the question is, which of those is the most likely? That's 2. That's pretty tough. After going through it, does it help some? Okay. You guys are all set for today. I wanted to get the test in before your like 3-day break, but it was too fast. So your 2.5-day break, whatever, yeah. So instead I added a little bit of the next chapter. So if you notice I think there's 2 or 3 more con assignments. And the test is gonna be next Thursday. So instead of like rushing to finish, we're gonna add a section and extend it a little bit. The new thing I added